When working with real-life application of trigonometry, we will come across the terms angles of elevation and angles of depression. Now, an angle of elevation or an angle of depression is always measured in the vertical plane from the horizontal plane. So let's have a look at the diagrams for this to make more sense. So an angle of depression is an angle measured from your horizontal plane, and that's going to go downwards. So this is called the line of sight. The angle of elevation is an angle that's measured from your horizontal plane but upwards. So your angle of elevation is measured from the horizontal plane upwards, and your angle of depression is measured from your horizontal plane downwards. Now this will make more sense when we look at the example at the top of page 83. The height of the Eiffel Tower is 123 meters, and the angle of depression to a tourist standing on the ground is 55 degrees. Determine how far the tourist is from the foot of the tower. Now guys, the one thing that you need to realize is that whenever they give you buildings and that kind of thing in a question, those are always perpendicular to the ground. So therefore, the Eiffel Tower will be at 90 degrees to the ground. Okay, so all your buildings are drawn at right angles. The angle of depression is 55 degrees. Remember, we're measuring this from a horizontal plane. So therefore, that will be exactly parallel to the ground. So therefore, if the angle of depression is 55, then the angle here would also be 55. That's your angle of elevation from the ground. Since these are parallel, that would mean these are alternate angles. So therefore, if your angle of depression is 55, then your angle of elevation from the ground will also be 55. Now, as it stands, you can probably see quite a lot of information, but it will make even more sense when we put it all onto a triangle and use our rules that we've learned so far when working with 90-degree triangles. So we're going to draw a triangle as follows. The height of the Eiffel Tower, we know, is 123 meters, so therefore that will be the side that's perpendicular to the ground. So that would be at 90 degrees. The Eiffel Tower is 123 meters. Remember, our angle of depression was 55 there, so therefore the angle we are interested in would be 55 degrees. We can call this triangle A, B, C. And remember, the distance we want is the distance from the foot of the tower to the tourist. So we're looking for side BC. Now let's see what ratio this works out to be. Remember, we are given AB, so that from this angle, that would be the opposite side. Our hypotenuse is AC, and the adjacent side would be BC. We are looking for side BC, and we are given the opposite side, so therefore opposite over adjacent tells us that the ratio that we are looking for is tan. So from 55 degrees, I can set up the ratio tan 55 is equal to the opposite side, which is AB, over the adjacent side, which is what we're looking for. AB has a value of 123, so we can put that in. And in order to find the value of BC, we multiply both sides by BC and divide both sides by tan 55. So we change the subject of the formula there. And now all we've got to do is to put that into our calculator to work out how far this tourist is from the foot of the Eiffel Tower. So it's going to be 123 divided by tan of 55 degrees. And that will give us an answer of 86,13 meters, and that's correct to 2 decimal places. So 86,13 meters, and that we did correct to 2 decimal places. So therefore the length BC, which is equivalent to the length from the base of the Eiffel Tower to the tourist on the ground, is in fact what we've just worked out as 86,13 meters. We have just seen how we can use Trig to help us to work out the lengths of the sides of a triangle.